So this video is about arrays, and I'll be talking about some very simple operations that you can perform on arrays. And for that purpose, small coding examples would also be shown. But before I actually start with the examples, I'll just give you an overview of what arrays are, and for that purpose, I'll be sharing my screen with you guys. Okay, so why do you require arrays and what are arrays? Arrays are primarily used to store contiguous memory spaces inside a computing machine. And why do you require contiguous memory locations? These are used for many different purposes. One of the examples could be that if you want to store uh, the scores that the students have achieved in their exams uh, against the name of the students inside a computer. For that purpose, you can use an array. And as it is shown in this slide, if you define the size of the array, which is 6 in this particular case, the index actually starts from 0 and goes up to 5. So there are 5 indices that are being shown here, and each index is representing a memory allocation. And how much memory allocation would be done at particular index, that depends upon the type of the array that you have defined. So here on the top left corner, you see that the declaration of an array is the syntax for declaration of an array is given. So you define the type. It could be integer, it could be float, it could be double, it could be used to store strings or characters, followed by the name of the array, and that could be anything. For example, you can name the an array that contains student information as student record, followed by the brackets, and within those brackets you actually write down the size of the array. So in order to declare the array that is being shown here, you have to write down 6 here, because uh, it would allocate 6 memory locations, and these are contiguous to each other. That means that they are not spread at different locations in the memory inside your computing machine. They are contiguous, they are side by side. um, and if the array is given a name which is x, then in order to retrieve the contents at index 0, you will have to basically write down x0, where 0 is within brackets, and 0 would indicate the first index place for this array x. And similarly, if you want to access the contents that are present at index 4, you will actually have to write down x4, where 4 is within brackets. So you have the contiguous memory allocation. Members of the array are represented by the name of the array, followed by the index of the array within brackets. And you also have to the index of the array has also to be defined, and that index of the array is defined by the size of the array. You need to remember this, that the index always starts from 0. So this is the declaration part. And then comes the initialization part. So if you want to store the scores of a particular student of six different subjects, let's say, then you can use the initialization of an array by putting an assignment sign after the array name and the size of the array, uh, followed by curly brackets within which a comma separated entries could actually be written. So for example, here you have 19, 10, 8, 17, 9, 15. These are 6 values. Those 6 values would reside at different indices of the array. So 0 index would correspond to the content 19, 1 would correspond to 10, 5 would correspond to 15. The sequence in which the the curly brackets that are being defined, the contents within the curly brackets that have been defined are placed. So the same order is the order in which uh, the index actually moves. So this is how a simple array is actually defined. So once an array is defined, you can use it for different purposes. As I told you earlier, you can use it to store the names of the students. You can use it to store the scores of the students. You can use it to store um, whatever you have that is in the form of a list. Okay. Um, so anything that has to be contiguous in nature, you don't want to store them separately at different allocations or different spaces, you can use arrays for that. And so this is how the syntax of defining an array goes. Um, so here is another example of an array which is of type float, and within brackets you can see that you have also initialized it. So the line in bold here, which is represented here, this line in bold is primarily representing the declaration as well as the initialization of an array. And then there are a few things that you need to remember. Obviously, the memory locations that are done, or the memory allocation that is done as a result of an array is contiguous in nature. The index starts from 0. Array could be of different types. And there are multiple operations that you can perform on an array. Okay. Um, right. So here is an example code which defines an array and it also displays the contents of an array, right? Um, so I'll just run this code for you, and then you will have a better idea that how this actually code performs. So let me open an editor. Uh, okay, uh, and I'll just write down this code there, and then we'll see that what is the outcome of this. Okay, so let me just place this code in an editor. I'll just share the screen with you in a while so that you can also see this. Okay, so let me just share the screen. Right, so I hope you can see this. So obviously, these are the essential initial lines that you'll have to write down for writing down code. Then the main code actually starts, and within that main code, we have defined an array of type float. And then within this for loop is actually used to access the contents. And because it is contiguous, therefore, if you increment the index by 1, you will move on to the next content or the next value that is present in that array. Okay, so let me just run this and see. Okay, so how many things are being displayed in this through the cout statement? There are primarily three things that are being displayed. The first is the index, which is represented by j. The second is the content of the array at that particular index. And the third one is the memory allocation, or the memory location at which that content is being placed uh, with respect to the index. And for that, you'll have to use this ampersand sign. You already know that. Now the setw command is actually used for formatting here, and I'll leave it to you to find out what this setw is actually doing. So let me just run this code and see that what happens. Okay, okay, and this is what you get. The first column that you are getting is the index, because the array is of size 6, as it is clear from the initialization of that array, followed by the contents of the array, followed by the memory location of that array. Okay, so you can well imagine कि ये contiguous है या नहीं है. I think again, if you look at this very carefully, you will find out that it's contiguous in nature. If I change the contents of the array, let's see, if I change 1 to 1.1, then you will obviously see that it's a float type, therefore 1.1 is actually being displayed. Okay, so this is how the contents are actually displayed along with the memory location that we have got. Okay, so let's move on to another example where what we'll be doing is that we'll actually be finding out the highest number which is present in an array. For that, you can write down a small code, and I've actually done that for you. And what I'll do is that I'll define a function here, which, I mean, if you look at this function, it's basically called location of the largest. So you are actually identifying the location of the largest value that is present in a particular array. The input, there are two arguments to this function. The first one is an array which is of type int and it's constant. And why is it constant? Because you don't want that the contents of this array be changed during the execution of this program, followed by a variable which is of type integer, which is n. And from this for loop you can identify कि ये n क्या represent कर रहा है. ठीक है. It's very easy to identify कि what is this n representing. uh, I mean, the code is in front of you, very simple code. You simply compare the first index, the contents of the first index with the second index, and you repeat this process for all the indices and find out the one that is the biggest. A very simple piece of code. Um, and let's just run this by writing a small uh, code in your main program. Okay, and let's just display that. Okay, so this is your main program. Let me just write down another piece of code here where you are actually initializing another array, which is a ARR1. The initialization is done by, let's say, some values here. Um y is representing the size of this particular array that has been defined, and then there is a function call here, and that function call would return the index of the highest value. Okay, so let me just okay, so let me just comment this part so that there isn't any confusion as such, and let me just run this code. Okay, so there seems to be an error here, and try to identify कि ये error क्या है, what is this error, and why is this error taking place. ठीक है, it's because that I have forgotten to comment this bracket, and I'll just run this again. Okay, and now you can see that index 0. Okay, in order to make it say a bit more visible, let me just run this again. Okay, so you can see this line here, it says 0, the highest index. Okay, 10 is placed at 0 index, so that's the highest. Let me just change it. If I change the fourth one to 40 and I run the program again, the answer should come out to be 3. So it's index number 3 at which the highest value is being placed. Right, so this is these are some of the operations that you can actually perform inside or using these different arrays. Okay, so let me just uh, remove this bit from here, and let's do another operation uh, of the array. And for the time being, let's just stop this sharing. I'll share the slides again with you, and we'll move on to the next bit of code that we have. Okay, so here is a small piece of code that would do what? That would push the elements of the array to the right hand side through a distance which is defined. So what will this do? This would push the contents of the elements which are present in your array to the right side. Okay, and for this you'll have to define a function, and the function would obviously take in a few arguments. The first one would be the array itself. It could be of a different type. Okay. um, it has to be an array which is represented by here, so you'll have to define an array and pass it as an argument. Then you'll have to start give the starting location of the content जहाँ से आप right side पे display I mean shift करना चाह रहे हैं, starting location and then the ending location कि आप किस component of the array को, किस sub array को आप move करना चाह रहे हैं to the right. एंड देन यू ऑल्सो हैव टू डिफाइन द डिस्टेंस के कितना डिस्टेंस मूव करना चाह रहे हैं. एक प्लेस आगे मूव करना चाह रहे हैं राइट को, दो प्लेसेस मूव करना चाह रहे हैं, थ्री प्लेसेस मूव करना चाह रहे हैं, या कितनी प्लेसेस आप मूव करना चाह रहे हैं. I mean, you can write down the logic for that. The code, a small piece of code is given here. One possible implementation is given here. You can go through this implementation. This is also uploaded on LMS, so you can download it and run it. But there are few checks also present here. For example, okay, so before we discuss this, let me just take this code and run it on in the IDE that I'm being using, um, and then I'll be sharing, okay, the screen with you. Okay, so let me just share this bit, share this the IDE screen with you. I've taken that code and I have just pasted it in the IDE. This is the function that is called in order to uh, implement the logic that we have. It takes in 4 arguments: the array, the starting point of the subarray that you want to move to the right, the ending point of that subarray, और फिर कितना distance आपने उसको move करना है. And then it's a small piece of code which would actually run. यहाँ पे there are certain conditions that are being applied. Obviously जो left value है, starting value of the subarray और ending value of the subarray जो है वो ऐसा नहीं हो सकता कि starting value greater हो जाए ending value of the subarray से. So that's not possible. Distance जो है वो zero नहीं है. I mean zero से कम distance अगर आप कर लेते हैं, zero भी कर लेते हैं, then there won't be any shift at all. So these are some of the checks that are being applied. And then here is the main code. The array has been defined. Is the same array जो कि हमने पहले define किया था. I mean you can change it. Then we are calling the function which is shift right. इसमें हम array को pass कर रहे हैं. Left side 0, so it starts from this position. Right is 3, so it's from this location to this location. That means 1 से 4 तक के जो contents हैं उसको उसने move करना है by one place to the right, and then यहाँ पे हम उसको contents को display कर रहे हैं. This is the same piece of code जो कि हमने पहले लिखा था. इसमें memory location को हमने निकाल दिया just for ease. Okay, so let me just run this program and see कि क्या होता है. Okay, and you can see कि क्या हुआ है इसके अंदर. I will leave it to you to interpret these results. I mean, it's very interesting कि first सेल के अंदर 0 इंडेक्स के ऊपर 1 पड़ा हुआ है और 1 इंडेक्स के ऊपर 1 है, and then you have 1 2 3 4, so it has been shifted to right. थर्ड इंडेक्स के ऊपर, initially थर्ड इंडेक्स के ऊपर जो था वो 4 था, अब फोर्थ इंडेक्स के ऊपर जाके 4 आ गया, तो that means that it has been shifted by 1. somehow 5 has gone away और फिफ्थ इंडेक्स के ऊपर 6 है. Now why this has happened, I mean I'll leave it to you to guess कि ऐसा क्यों हुआ है. Okay, so this is a small introduction about arrays. There are other things that you can do with arrays. For example, if you want to eliminate duplicates in an array, you can do that. If you want to find out the smallest number in an array, you can write down a small piece of code for doing that. If you want to, let's say, delete something from an array, you can do it. You can write down a small piece of code for that, but you have to keep this thing in mind, that the one that I've told you right at the start, that arrays are contiguous allocations of memories. Okay, and then obviously the index starts from zero, or zero mein agar if I add one, I'll move on to the next content of the array. If I add two, I'll move on to the second index, the third index place, and so on and so forth. And this actually continues. ठीक है. Obviously there are few limitations which are associated with arrays, and one of the limitations is that if you let's say if you want to have a very large array जिसके लिए बहुत ज़्यादा आपको memory allocation चाहिए. For example, if you want to store the names of, let's say, students that are present in let's say Punjab, let's say, तो उसके लिए आपको मेमोरी एलोकेशन बहुत ज़्यादा चाहिए होगी, और एक पीस ऑफ चंक में नॉट बी पॉसिबल, लाइक वन कॉन्टिगुअस पीस ऑफ चंक में नॉट बी पॉसिबल टू एलोकेट. तो उस सूरत में आप क्या करेंगे, अगर आपके पास बहुत ज़्यादा कंटेंट है और कॉन्टिगुअस पीस ऑफ मेमोरी एलोकेशन आप नहीं कर सकते, तो उस सूरत में अरेज विल विल हैव अ लिमिटेशन. यू कांट डू दैट विद अरेज. ठीक है, उसके लिए आपको कुछ और सोल्यूशन जो है वो ढूंढना पड़ेगा. Okay, so this is about arrays. I think this introduction is enough and should help you in kickstarting your say programming with arrays. And as we'll move along, we'll also add to the complexities that are associated with that. For example, accessing the contents of the array using pointers and different other forms, right? So we leave it to our next video जहाँ पे हम pointers की description करेंगे. But for the time being, I think this small introduction is enough. So thank you very much for your attention. I'll leave it here.